I am Christian Sormann from Graz University of Technology, presenting our work DELS-MVS, Deep Epipolar Line Search for Multi-View Stereo, a novel approach for deep learning-based multi-view stereo. For each pixel in the reference image, our method leverages a deep architecture to search for the matching point in the source image directly along the corresponding epipolar line. Our dynamic exploration of the epipolar line means that we are not limited to a predefined minimum and maximum depth range. Furthermore, we do not have to construct a large cost volume or define a depth discretization scheme. Finally, we propose a geometry-aware confidence-based fusion of depth maps originating from estimations conducted with different source images. Our algorithm starts from initialization directly on the epipolar line of the source image. The goal is to estimate the distance on the epipolar line from the projection of the initial estimate to the projection of the true depth, which we denote epipolar residual. Once this is determined, we can compute an updated depth estimate resulting from the reprojection of the match found in pixel space into depth space. On this slide, we give an overview of our entire system. Deep features are used as an input for our epipolar residual network, or ERNet. This network guides the DELS algorithm, which is used to estimate the epipolar residual. The result of our epipolar residual estimation is a dense depth map for each source image. In addition, we also estimate a corresponding confidence map for each source image depth map. This is done via our confidence network CNET. Our iterative classification approach for estimating the epipolar residual works as follows. We split the epipolar line around the projection of our current depth estimate into several partitions and distinguish between inner partitions and outer partitions. The inner partitions model that the matching point on the epipolar line between a reference pixel and a source pixel lies between the inner partition boundaries. The outer partitions, on the other hand, signify that the matching point lies either to the left or to the right of the inner partitions, thus yielding a direction to move towards. Our algorithm relies on ERNet, which, given the current partitioning and deep features, estimates in which partition the match on the epipolar line lies. We distinguish two cases. As shown on the left, in case the estimate is contained within one of the inner partitions, we shorten the partition length and run ERNet again, until we reach a lower bound for the partition length. As shown on the right, in case the estimate is determined to be in one of the outer partitions, we take a step towards that direction. In our fusion step, we aim to provide a single output depth map by utilizing the depth and confidence maps obtained by running the DELS algorithm using multiple reference source pairs. To this end, we initially select suitable candidates for each pixel based on the estimated confidence map from CNET, and then further select a candidate from the source image with the smallest bin in depth space calculated from the corresponding epipolar line partition. We then compute the final depth estimate as an average between this candidate and source candidate sufficiently close to it. Next, we present point cloud results of DELS-MVS and compare them with results from other methods. Here, we show RGB point clouds in the first row, completeness in the second row, and accuracy in the third row. We can see that in terms of completeness, our method outperforms the other two, while achieving competitive accuracy, which leads to an improved overall F-score. In terms of quantitative results on the ETH3D benchmark, our method performs similar to the traditional methods ACMM, MAR-MVS, and PCF-MVS, while outperforming other learning-based methods. On the Tanks and Temples benchmark, we perform very close to the state-of-the-art methods on both the intermediate and the more challenging advanced set. This concludes our presentation. Thank you for your attention.